The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Okay, and away we go. Hi, everybody. I'm Josh. I am here to talk to you about debugging applications using OpenTelemetry. Thanks so much for sticking around and coming to my session. Right, so like I said, my name's Josh. I am an open source advocate at Altinity. We are a services provider for ClickHouse, which is a massive analytics database that a lot of observability vendors use for their distributed traces and logs and things like that. So if you're interested in sort of home brewing or building your own observability platform based on some of the concepts that I'm going to be talking about today, then please come find me. They paid for me to be here, and we're very grateful. And yeah, anything we can talk about helps me keep doing this. So with that out of the way, oh yeah, and our lawyers wanted me to put that there, so that's there. All right, so let's get into it. What I want you to be thinking about while I'm up here speaking today is this question, right? This is really the goal. I'm going to use some words that you've heard from a lot of vendors. You've heard marketing buzzwords around them, right? But at the end of the day, really simply, our goal is to keep our applications healthy and to fix them when they're not healthy. Everything else is in service of that, okay? So how do we debug our applications? Like this, right? That was a quick talk. That was pretty easy. No, so we're laughing, right? This is funny to all of us because we know the truth. We know that this is the easy part. The hard part is getting to here, right? And so really what we're talking about is like, how do we get to this faster? How do we get our mean time to Google lower? We use observability. And so there are a lot of different definitions for observability out there. Some of them come from like the mechanical engineering world where it was originally used. Some of them are going to come from various influencers and vendors and things like that. But really, if I had to sum all of those definitions up as it applies to what we're talking about, it's two things. It's visibility and understanding. Can you see what's happening from the system's outputs? And upon seeing it, can you understand it enough to make changes and make it behave in the way that you want it to? So that's really it. That's the goal, right? That's how we debug our applications, is with the combination of visibility, understanding, and control. An airplane, right, a modern jetliner, we can kind of think of this as like a good analogy for a modern microservices application. You have a lot of different interconnected systems, each responsible for some subsystem within the airplane. They're maybe more interconnected than we want them to be, right? Like with spaghettiification and dependencies and things like that. So there's a lot of stuff going on. It all has effects on the other things going on. There are external factors, and the pilots need a way to manage all of this and control all of this. So they get this huge array of dials and gauges that give them information, and then all the buttons and levers that they can use to put control inputs back into the system and to get it to behave, right? So this is great, but it's a little bit overwhelming. If we take a step forward a couple decades, right, this is a more modern cockpit. That other one was from the 70s. This is a 787 Dreamliner, which was designed, I believe, in the late 90s or early 2000s. And first, one thing I want to point out, there are still a lot of buttons here. There's a really good reason for that. If you've ever tried to fly an airplane in turbulence, or if you've ever tried to use like a touch screen in your car while it's bumpy, right? Like touch screens, not great for controlling vehicles, especially airplanes. So Boeing did try to make a cockpit that was all touch screens, and pilots hated it universally. So that's not how we're going to do the buttons. But the dials are gone, right? The gauges are gone. Those have all been replaced with these 4 central screens. And the main difference here is that instead of having to look around for the specific thing that I care about and then look around for the other thing that correlates to it so that I can, right, that work is being done for me and the context is being brought directly to me so that I can look at only the information that I need in the moment for whatever I'm trying to do right now. And to me, that context is a big part of that understanding that enables observability, right? And it's what enables us to act and think quickly on our feet when we're in the middle of debugging an incident, and every single error really adds up, right? If we misread something. So how do we actually do this in our modern applications, right? So Charity Majors is from Honeycomb. She has some great blog posts and opinions about observability. If you haven't heard of her, I definitely recommend that you go check out her stuff. Honeycomb is also a great observability company. They're doing really, really interesting things and kind of responsible for defining the whole industry as it exists today. Now, Honeycomb is a distributed trace-based observability tool. So why is Charity saying there are only two signals, metrics and structured logs, if her tool depends on distributed traces? Well, distributed traces are kind of just like the best structured logs we could ever have, right? But show of hands, who has not heard of or used distributed tracing? Okay, cool. That's okay. We're going to go into what it is. That's fine. All right. So stepping back a little bit, let's talk about logs. Now, I actually used to make fun of logs at the beginning of this, right? I had the joke about Google, and then I have another joke about how much we all have to read logs. And everyone laughs at that too, because we've all been there. We've felt that pain. But I think maybe logs aren't actually that bad, right? At the end of the day, they're going to be the thing that we read that gives us the final information that helps us get back to Google, right? So the logs are really important. It's just about finding the right ones. That's really the pain point. So here we have a typical request log, right? We've all seen this many, many, many times. Hopefully you're storing it in some sort of structured format like JSON, but for ease of reading, we're going to look at them like this today. Right, we've got our timestamp, we've got our HTTP verb, we've got our endpoint, and we've got our status code. That's actually a lot of information if we have this for every single request, right? There is one thing missing that we really need to make this extra useful, which is the duration. So throw duration on there, right? All of a sudden, we can build this just from those simple log lines, right? If we have those log lines for every endpoint in our system, for every service, we can start to build what Google would call the golden signals, what I like to call RED metrics, right? Requests, errors, duration. So how many requests were there, what percentage of them contained an error, and what was the average latency? And with those three signals combined with Google rounds out, the golden signals includes the saturation of the hardware that the services are running on. With all of that, you have a very, very good understanding of the overall health of your system, and you can start to define what healthy things look like, what healthy boundaries look like for these numbers, so that you know when there's a problem that you need to dig into deeper, right? And so this is really awesome. But it also is, right, like it's an aggregate. It's not letting me dive into a specific issue and debug it. It's just telling me about the overall health of the system. It's answering the question, is there a problem? So we go back to our log, though. I think we can make it even better. So around 2016, I was working at a startup, and we started, we were like, oh, microservices, right? This is so cool. We're going to have more services than we have employees or customers. So that has its own problems. But we're like, okay, how do we deal with like logging now that we have all of these different services? And so everything's emitting logs, but like, how do you know which logs you need to look at? And we had this brilliant idea. We weren't the only people to have this idea of putting the request ID in every single log message, not just in the API, but in all of the downstream services that were also processing part of that request. Now, that was really, really powerful because it gave us this like bag of logs that we could look at anytime there was an error with a request, and we could kind of see all of the relevant logs for that request. This is great. This gives us a user-centric point of view to start debugging our application and to start understanding errors. But it also had some problems. One, it was really hard, right? Even within our homogeneous single language ecosystem that we had complete control over, we had to start propagating these request IDs and make sure that they were faithfully propagated to every downstream service, and that whatever processing happened in that service, it could also get propagated to the downstream HTTP calls that service was making, or database calls, or whatever, right? Messaging queues. So we had a propagation challenge that even within our very confined environment, that wasn't trivial. And then the other thing is, right, on the back end of this, when we're reading the logs to diagnose a request, we just get this big bag of logs. And we can use the timestamps to kind of piece together the story of what happened, but it's not, we're guessing, right? It's not guaranteed. So we can make it even better, right? We can connect it. And we could give each single log message its own ID. and also record the parent ID of the request that preceded it, right? And so what we end up with is a trace. That's the overall HTTP request that hit the front-end API and started this whole trace, right? And then each sub-request is called a span and has its own ID, and then it has the ID of the overall trace and of the parent span that precedes it. And what we get from this is a nested tree structure that basically encodes that debugging journey for us, that journey of like figuring out what happened here, what called here, where was the error, right? It's all just encoded in the tree structure for us. And we can build this awesome waterfall graph that looks kind of like Chrome developer tools, right? Everyone's familiar with that when you're looking at the front end, but this is for the back end. So this is really, really cool on its own. I love this visualization, right? This is immediately obviously useful, especially with the comparison to Chrome developer tools, right? If we're talking about performance analysis or we're trying to diagnose latency, we can see exactly where the latency is coming from in our system. We can see the exact order of operations. We can zero in on exactly where an error occurred in a specific request. This is great. But we can even do more with this when we start to aggregate the traces, right? And I'm going to talk about that in a little bit. First, real quick, right? Just to ground us again, observability is not any one signal. Metrics are great, as we talked about, for answering the question, is there a problem? Traces are great for telling you where the problem actually is. And then those traces are going to lead you to a log message that has some verbose information about what the problem actually is. So we kind of need all of them, but we don't necessarily. So then why did Charity say that, right? Why is it there's only metrics and structured logs? And then I'm going to tell you actually that you don't even need metrics for most things. So because, right, the trace, we kind of looked at how the traces are just logs. Metrics are aggregable. The way that things like Prometheus work, which we heard mentioned before I started talking, right? The metrics get pre-aggregated at the source that's emitting them, right? And so you just sort of get the metric is emitted based on the time bucket that you're looking at, right? And it's pre-aggregated and you scrape it and you have to know in your backend how it was aggregated so that you can represent it faithfully in your charts and things. I would argue that if we're really all in on distributed tracing like this, we can just start to count things to get those metrics, and we can count those things in the backend. Because one of the really, really cool things about distributed traces is they're not limited in cardinality the way that metrics are, right? So cardinality is the total number of possible values in a specific field, right? If we had a field that was US states, the total maximum cardinality is 50. That's a nice low cardinality number that we might put in a time series metric, right? And then we would end up with 50 unique time series based on that cardinality in that single dimension. There might be other dimensions, right? But this is how we get our Datadog bills like totally out of control when there's cardinality explosions. In tracing, you don't have to worry about cardinality explosions. You can put totally unique identifiers, things like first names, user IDs, product IDs, right? It doesn't matter because we're not creating entire new time series that have to be tracked. It's just metadata on an event. And then from that, we have all of those dimensions that we could ever want to count things across. And we can recount based on filtering, based on various dimensions. What applies to this region? What applies to this product? What applies to this user, right? So we get a lot more. And that's part of why I think distributed tracing and wide events are kind of the killer app for observability, right? First, they let us understand the complete flow through our system for an individual request. We looked at that in the waterfall graph. They let us create a map, right? If we aggregate all of those complete flows, we then have a map of the topology. We know every service within our system and what other services it talks to and under what circumstances. We can count things, right? We can derive metrics from that richness and all of that unlimited cardinality and dimensionality that we have in our traces. And we can make the logs a lot easier to find by attaching them to the specific trace that is relevant for that log message. So we've made our metrics more detailed. We've made our logs easier to find. We have a real-time topological map of our system that's actually accurate based on real traffic, right? We don't have to go make sure the documentation is up to date or see if the senior architect actually remembers correctly. There's no question. It was based on network traffic. So that's great. But like I mentioned when I was talking about that request ID that we had to propagate, right? That was not a trivial problem. And the way that it was originally solved for folks was through vendors, right? So vendors would give you a tool, and you would install their SDK, and it would handle that propagation for you using their proprietary formats. And then it would send all of that data back to their backend, and you'd get those nice trace views. Well, this is great, except that, well, unlike logs and metrics, which are kind of just like text that you just emit, right? Now we need these things that are getting put into all of our own artifacts. And these things are coming from vendors. And that's kind of icky. And then there's other problems with it, right? Like if I'm a maintainer of a library, say I maintain Django, right? And I want to put some observability built into Django. Well, which vendor do I pick? Which vendor's SDK do I use? Do I have to use all of them? That's kind of a pain, right? So what was really needed, was a vendor-neutral way to do distributed tracing. We already had Prometheus for metrics, which is more or less vendor-neutral because it's just text, right? It's just tags and numbers. So that's very easy to do in a vendor-neutral way. And again, logs, also just text, very easy to do in a vendor-neutral way. Distributed tracing required something more. It required some open standards, and it required some open tools. And that is what the OpenTelemetry project has brought us. And it also is an instance of compaction in the number of standards, right? So there used to be two standards, Open Census and Open Tracing, circa like 2017, 2018. And they merged together into the OpenTelemetry project. And as I mentioned before we started, the Prometheus project is now even co-evolving, as they say, with the OpenTelemetry project, and we're starting to see these standards converge rather than diverge, which for observability is just freaking awesome. Like kudos to the whole industry for this. It's amazing. It's amazing that it exists. All right, so what actually is OpenTelemetry? Let's get into it. For most of us, it's going to be the SDKs. This is how we're going to interact with it. This is how we're going to get it into our services. The SDKs currently support these three signals. There are a couple of new signals coming down the pipe. So events is an exciting one that's sort of like a specific moment in a trace where something happened that was interesting. And then there's profiles. So profiles would be like your stack trace profiles, or your detailed profiling of a specific individual process running on a specific individual machine. And that's really, really powerful for performance analysis and resource utilization analysis. But for now, we have these three signals, right? So metrics, traces, and logs. And then the SDKs are in various states of stability. This hasn't been changing a lot lately, and a lot of the things that are marked beta out of an abundance of caution. You can kind of check like who's using these SDKs, especially for tracing, right? Like they're very mature. Logging is the newest signal to have its specification finalized. That happened in late 2021. So the SDKs are sort of still coming along, because again, a lot of this is done by volunteers. It's all open source. All right, but it's more than just the SDKs, actually. It's a lot more than just the SDKs. I don't have an awesome, right? If anyone went to any of the Nix talks, I don't have an awesome Holy Trinity thing, but maybe there's one in here. All right, so it's three things. To me, this OpenTelemetry really is these three things, most importantly, right? It's the specifications. These give us the universal format that make everything interoperable, so it can all talk to everything else in a vendor-neutral way, right? Then we need the libraries and tools, which let us actually use those specifications so that we don't have to like write everything ourselves from scratch. And then it's the community that allows those things to exist, right? So within the specifications, one of the most important ones is the W3C trace context specification. This is the specification that says how those trace IDs and span IDs, and there's some other stuff that you can put in there that you can pass down, goes into the HTTP headers and then gets interpreted by the downstream services. So basically what this specification says, right, if you're receiving a call that has these headers, you should pull out those headers and hold on to them and make sure that they get propagated into downstream calls. And then you should also use them to inform any traces or logs that are being emitted by your service, right? It uses those headers to identify the trace. Then we have the language APIs. So these are the actual APIs for the functions that you would call within your code to generate telemetry, right? Like give me a span, add this metadata to the span, things like that. And the APIs out of the box come with a no-op implementation, which is really cool, because that means that I, as the developer of Django, right, to use our example from earlier, I can go litter Django with these API calls, and it won't actually do anything until the end user who's building a Django application provides an instance of OpenTelemetry SDK with configuration that replaces the no-op implementation for the API calls and starts to do whatever I, as the ultimate end user, wanted to do with that telemetry, wherever I wanted to send it, however I wanted to process it. So that's a really powerful abstraction that allows libraries to be instrumented. But as an end user, you don't have to think about that too much, right? You're going to call the API calls, you're going to configure the SDK. Then there's OTLP. This is the wire protocol. This is how all of those 3 telemetry signals and the future telemetry signals get translated over the wire. To me, this is one of my favorite parts of OpenTelemetry because basically it means you're not locked into these implementations, these official implementations, right? As long as your tool speaks OTLP, it's going to be compatible with everything else that speaks OTLP. And this is how a lot of the vendors are supporting OpenTelemetry, right? They're giving you an agent that's still a vendor-specific agent, but it's ingesting OTLP. So you're not putting their SDKs in your code, you're putting open source SDKs and then talking to a proprietary agent that has some additional ergonomics or enhancements on it to make your life easier. So we get the best of everything, and it's all possible thanks to OTLP, my favorite part of OpenTelemetry, combined with the semantic conventions, right? Naming things is really, really hard. It's one of the hardest things we do, and especially in observability, right? When we're trying to look at things like metrics or logs, say one service was emitting it as status code with camel case, another one was status underscore code, right? And that's just a basic example, but you can imagine how this proliferates across the many, many dimensions that we might have in our observability system. And that's like one of the main things that SRE and observability teams spend their time managing is just like, hey, can we just have consistency? Well, OpenTelemetry now gives us a standard, so we can all just follow the OpenTelemetry semantic conventions, and we're going to have that consistency within our own organization and across organizations. Extremely useful. There are semantic conventions for most of the things that you care about, like HTTP calls, messaging queues, processes, services, Docker containers, right? A lot of these things already have semantic conventions. If there's something that doesn't exist yet in the semantic conventions, you can throw that metadata in under like an app key, which we'll look at in a little bit, that says like, this is my thing that's not part of the semantic conventions. Or even better, you could contribute, right? Just open a PR and say, hey, I noticed there weren't semantic conventions for these things. This is what I call them. And now we all can kind of speak the same language. So the semantic conventions are awesome. I don't think they get enough credit. We have the language SDKs. I mentioned these already, right? This is actually how you provide the implementation inside your service and tell it what you want it to do and where you want the telemetry to be exported to. We have the instrumentation libraries. So what these do is, like, say the guy who made Django, or the people who make Django, didn't put all of that instrumentation in it out of the box, but I want instrumentation for my Django application. Well, there might be an instrumentation library that knows how to watch Django and give me telemetry for it, right? So basically it translates from, an instrumentation library translates from some other library that you're using to the OpenTelemetry API and gives you instrumentation. I give a whole talk about that that's on YouTube from KubeCon and some other conferences. So if you want to know more about that, go look up me and auto instrumentation. All right, and then we have the OpenTelemetry Collector. This is kind of like the project's replacement for what a vendor agent would have traditionally done, right? So the collector does a lot of things. It's kind of a Swiss Army knife. We're going to talk about it more. But in short, it's a replacement for an agent. And then we have the Kubernetes operator. This is just an ergonomic tool. What it does is it can deploy the collector for you in your Kubernetes environment as a cluster agent or as a node agent or both. And it can also apply those instrumentation libraries automatically to certain pods in some languages. So OpenTelemetry project supports 11 languages. Those were on the slide earlier. The 5, I believe, that support auto instrumentation is Ruby, PHP, Java, Python, and .NET, and kind of Golang. I'm going to talk about that in a little bit. But Go as a compiled language, the auto instrumentation strategy gets a little different. Then we have the community, right? OpenTelemetry is the second largest project under the CNCF, the largest being Kubernetes. I think this kind of makes sense, right? OpenTelemetry touches everything, so all of us are going to be making some kind of small contributions back up to it for the things that it touches that are relevant to us. So if you're looking to make a name for yourself, contributing to OpenTelemetry is a very, very good way to do it, because like it's a high visibility project and widespread. It has a little something for everyone. It's events and meetups like this. Thanks for coming. There's also a ton of CNCF events and online events. And then, right, it's the online meeting groups. So one that I definitely recommend is the OpenTelemetry End User Working Group. They do interviews with companies that are actually using OpenTelemetry in production. There's some great recorded ones out there. There are also many, many other working groups and SIGs, special interest groups, right? There's one for each of the 11 languages. There's one for like front-end telemetry. There's one for storage. There are a ton. If you Google search OpenTelemetry Community Calendar, I believe you will find a GitHub page that lists the calendar for all of these meetings and also their Slack channels. You can go into the Slack channel, message the maintainers or the organizers of that special interest group and say, hey, I have this thing I want to talk about. And they'll let you know when would be a good time to bring it up at one of their weekly meetings. So this is a great way to get involved. Okay, so let's talk about the technology a little bit, right? So we've kind of been talking about the different pieces. We have the stuff that goes in our service. We have that OpenTelemetry Collector that I promised we would talk about a little bit more. And then it all goes somewhere, right, to some backend. Now, importantly, the OpenTelemetry project very explicitly does not include anything for that yellow box. There are tons of open source and vendor provided options, but the OpenTelemetry project itself is strictly focused on the purple and the blue, right? The stuff on the left. This is all stuff that used to be vendors, right? There was really no open source way to do that. Now the vendors are kind of relegated to that last box, and so they're all competing on, well, what can you actually do with the data, right? Which I think is interesting. I think it makes it more competitive and more fun and more exciting. And then we also have a ton of open source tools coming up for that yellow box, right? But if we were to make it a little bit more specific, here's a more specific architecture. I'm going to zoom in on these, so if you can't read these, don't worry, we'll zoom in. Also, the slides are online. But basically, we have our service, then we have the OpenTelemetry Collector, and then our backends, right? We're going to have storage. We're going to have some kind of mechanism of doing ad hoc queries on our telemetry. We're going to have some way to build dashboards based on those ad hoc queries, and we're going to have some way to do alerts, right? And those are the basic components of the backend. But let's dive into the OpenTelemetry parts. We're going to have some stuff in our code and on our node, and then somewhere else, right? This is going to map back to the things we were just talking about. So in our code, we have the language API and SDK. We have processors and exporters. OpenTelemetry is extremely extensible, so these are plugins. The most common ones you're going to use in your actual code, in your SDK, is going to be the batch processor, and then the OTLP exporter, which is the default one that's configured out of the box. Just use that. You will see in the project there are some exporters that are like using vendor-specific formats. Those should all be deprecated at this point. Don't use those. Just use OTLP. The whole industry has sort of agreed. We're just going to speak OTLP. We're going to get rid of these vendor formats. Instrumentation libraries. Right? Basically, just install the instrumentation libraries that correspond to the libraries that you're using. If you're using Express.js, there's an instrumentation library for it, and it'll give you out-of-the-box instrumentation. Very convenient. And then manual instrumentation. So the instrumentation libraries themselves, they don't know about things that matter to you, right? They only know about the framework or the library. It knows what an HTTP request is, it knows about error codes, but it doesn't know about things like product IDs, order values, revenue, regions, right? Any of these things that might be important to you, business units, however you divide things, however you get this telemetry to the people who actually care about it, right? So that's where you're going to have to go in, and even if you're using the instrumentation libraries, add some API calls to sort of manually get these dimensions in. All right, then moving on to our node, this is where the OpenTelemetry Collector goes. And the asterisk is there on node because there's lots of different ways to deploy the collector. You can also deploy it as, in Kubernetes terms, right? Like usually you'd deploy it as a daemon set, and you get one instance on every node, and it would be gathering metrics from that node, as well as gathering the telemetry from any services running on that node. But you can also deploy it as a deployment, and sometimes you might do both, right? Because the deployment can act as the gateway that's doing the final export to your backend, because a lot of databases don't like to have more than, say, 1,000 open connections at a time. And so you can have this sort of pipeline that funnels things from your daemon set through to your backend. But generally, you're going to have at least one OpenTelemetry Collector running on every node. It's also extensible. This is where you're going to have a lot more fun with the extensions, right? because this is actually where you're kind of starting to combine. Some of your stuff was instrumented with OpenTelemetry, but I'm guessing in most situations, you're going to have like 6 or 7 other things running in production that you're also going to want to gather that telemetry from. And so the OpenTelemetry Collector, first of all, has like over 90 plugins that you can use as receivers. So you could, for example, use it to scrape Prometheus metrics without using a Prometheus agent. Or it can also, the receivers can also be they can be push or pull, right? So you can follow the Prometheus remote write protocol, or you can have other, right? There's tons of different receivers. It can pull things, it can expose an endpoint. There's one for SNMP, yeah, just go to the GitHub, there's a huge list. Processors. Again, the batch processor is going to be really important. That's going to help you manage constraints between memory, like the larger your batches, the more memory your collectors are going to need, but the less network traffic they're going to use. So it's kind of up to you how you want to balance those things and how you want to configure the batch processor. And then exporters. Again, the OTLP exporter is going to be the most common one, but there are also a ton of others, right? So like, for example, I work for a company that does ClickHouse. There's a ClickHouse exporter that can just take all 3 of those signals and dump them right into your ClickHouse database, which is really, really cool. There's tons of exporters for other databases, right? Like OpenSearch and yeah, again, go to GitHub. There's a very, very long list. All right, and I mentioned this, right? The OpenTelemetry Collector itself, one of the receivers is the host metrics receiver. That's going to gather metrics about the actual resource utilization on the host that the collector is running on. You can also gather logs, right? Like from the file log receiver is another one that will gather logs directly from Kubelet. So that's very convenient. And also, we have this automatic instrumentation, right? This is happening on the node, maybe through the operator, maybe through environment variables that we're passing into the workloads. But automatic instrumentation is happening at a node level, not at a code level, most of the time. Depends how you define automatic instrumentation. Go look at that other talk. It's a big topic. Okay, where does this all go, right? In our code, this is just kind of a map to show you how it all fits together. So you're going to have your custom instrumentation. That's going to be your calls to the OpenTelemetry API functions. You're going to have the library instrumentation. That's the stuff that's also calling OpenTelemetry API functions based on the libraries that you're using in your code. You're going to provide an instance of the OpenTelemetry API so that all of those functions are available. And then you're going to provide an instance of the OpenTelemetry SDK configured with whatever processors and exporters you want to use. And the OpenTelemetry API is going to talk to the SDK, and the end result will be you get telemetry. So that's everything that goes inside our service. The OpenTelemetry Collector. This has 4 types of plugins. So we talked about receivers a little bit. We talked about processors, right? Those. So there's some other processors that I didn't mention, right? So there's the batch processor. There's also one called the OTTL processor. So this can like do transformation on your metadata based on rules or regexes that you set, right? There are a bunch of really interesting processors, bunch of really cool exporters. And then there are these things called connectors. So what connectors do is they take the output from one exporter and pass it into the input of another receiver at the beginning of another telemetry pipeline. Why would you want to do that? Well, the most common connector is called the span metrics connector. So this does exactly what I was talking about 15 minutes ago, where we're counting the number of events and then using that to generate a metric. This is happening at a node level, not in the back end, but I think that's still an improvement over doing it right like at the actual source, because we still have a lot more control and configurability at this layer, right? Without changing as many things, without as big of a blast radius for changes. So yeah, the span metrics connector is really cool, but there are other ones, right? And you don't just have to count things like RED metrics, right? You could have a connector that counts something like order value for every checkout span. And then all of a sudden you have a metric for your total sales volume. Really, really cool. And you can just slice and dice that metric based on any dimension that you want from those unlimited cardinality dimensions that we have in our traces. So this kind of makes the OpenTelemetry Collector like a Swiss Army knife. Oops, wrong slide. Anyways, yeah, so it does all these things. It gathers and forwards your telemetry. It applies your filtering, your sampling, your batching rules, right? Your transformation rules. And it can translate between any compatible source and destination. And it's gathering your node level and cluster level telemetry. And then that is a deep dive article on the Alternity blog where I kind of go into the OpenTelemetry Collector specifically in a Kubernetes context, right? This blog post is really about using it in Kubernetes, if that's interesting to you. So yeah, it kind of makes it into this Swiss Army knife where I can take like any of these formats on the left. These are just some of the ones that I run into very often. And I can send all of it to any of those formats on the right. Now, one of the ways that vendors will sell this to you is like it's vendor neutral. And when they say vendor neutral, what they mean is you can change vendors whenever you want to, right? Like if you change from vendor A to vendor B, it's not going to be as painful. They're kind of right about that, right? Like the fact that we don't have their SDKs and their code littered in all of our code artifacts and built artifacts does mean that that is true, that it's going to be a little bit easier on that day that we decide to change vendors. Fewer teams are going to have to be involved. So that's nice. But I don't think that's actually the true beauty of vendor neutrality, right? I think the true beauty of vendor neutrality is that all of these things can work together all the time. So if you have one team that really, really loves Grafana and you have another team that really, really loves Datadog, they can both have what they want. And they can be looking at the same data emitted through the same pipeline. That's powerful. That's why vendor neutrality matters, not because, oh, you're just going to use it as a wedge during contract negotiations with your observability vendor. All right, so how do we actually use this thing, right? Let's show some code. First, we have to instrument our application using all of those things that we talked about that go in our application, right? We have to add our additional manual instrumentation and context that matters to our business and our teams. Then we need to deploy an instance of the collector to gather all of that telemetry. And finally, we need to send that somewhere to do something with it. Ideally, we're going to look at it and analyze it, right? Otherwise, we're just paying a lot of money for storage for no reason. So the first step, instrument your application using the OTel API, SDK, and instrumentation libraries for your language. This example comes from the OpenTelemetry demo project, which is an awesome project that I'm going to talk about towards the end. So this is 5 includes, right, in Node.js. It would be nice if it was like 1 or 2. That would be nice. But the OpenTelemetry project is extremely configurable and very much kind of just hands you a bag of Legos. And then it's up to you to build the solution that you want from that bag of Legos. But this is not that bad, right? Like that's not that bad. And then I omitted it, but there's only 12 more lines to this file. And that's the complete instrumentation for this entire Node.js service with like 17 different endpoints because of the power of those auto instrumentation libraries, right? So you don't need to go in and edit every single service. You just configured one file that said like, hey, this is where I want you to send telemetry. And oh, by the way, I'm using Express. Done. Okay, then we can add additional manual instrumentation and context. So in order to do this, we just have to get that context variable, and how you get that context variable is going to vary from language to language. But once you've got that context variable, you can go ahead and use it and add additional context, change the context, do whatever you need to do. Maybe you want to create an internal span, right? Like not every span has to represent an HTTP call. So if you have some really, really expensive function that's like looping over some really big objects or hitting the file system or something, you might want an internal span for that so that you can track that before we go over the network to another service. Then we need to gather and process telemetry with the collector. The collector is configurable through YAML. In the YAML, you give it a pipeline you define pipelines, and the pipelines operate on a single signal type. So you'll have a pipeline for metrics, a pipeline for at least one pipeline for each of them, right? You can have more than one pipeline, but you're gonna have at least one. And then within the pipelines, right, you're gonna configure receivers. So here's an example. I mentioned that you could use the OpenTelemetry Collector to replace your Prometheus agents. Yes, you can. And you can configure your scrapers like that. And then we need to export, right? So our exporters are usually just going to look like this. It's going to be like, here's my endpoint. Sometimes here's my authorization key. Here's a couple of settings for how I want this data to be stored. But it's usually going to be pretty straightforward, right? This would look very similar if we were sending this data directly to a vendor. It would be like the vendor's endpoint and my API key that I got from the vendor dashboard. Okay, that's it. We're done. Everything is awesome. Kind of. Kind of. Don't run too fast, right? There are some pitfalls and warnings. This is getting better and better all the time, right? This project is maturing very rapidly, thanks to the extreme efforts of the community. But we kind of mentioned one of these already, right? There's a lot of stuff to stitch together. Right now, OpenTelemetry is very much a bag of parts. One of my hopes is that vendors will take it upon themselves to provide easier to use implementations of some of these things, so that maybe the open source ones can be like the reference implementations, and that can be a way that vendors can sort of contribute back to this, even though they no longer have complete control over the whole pipeline. The specifications are semi-stable. This is kind of true. Last year, this was a big challenge. Last year, there was a huge upheaval because the HTTP specifications changed. As you can imagine, a lot of tools depended on those specifications, and then you all of a sudden have to deal with versioning in a system that had never had to deal with versioning before. And so that was a pain, but we got through it. And there's also a very strong commitment to only making these backwards incompatible changes when it's absolutely necessary. Mostly, we're just adding stuff. All of the SDKs are idiomatic to the source language. This is a pro and a con, right? It depends who you are and what you know. So, for example, the OpenTelemetry Java SDKs try to be as idiomatic to Java ways of doing things as they can. That's great if you're a Java developer and you're already used to that. It's less great if you're like a central observability team trying to instrument a bunch of stuff that you didn't write and you're not an expert in that programming language or that ecosystem, right? And what I would say in that case is, like, if you're a central observability team instrumenting stuff that other people lobbed over a fence at you, maybe don't do it that way, right? Like, maybe you should be supporting them in instrumenting their own stuff. Duplicate data can confuse tools. Don't combine OpenTelemetry with other monitoring things in the same process or on the same node. First, there's the challenge where, like, some of the things with auto instrumentation will start to auto instrument each other in an infinite loop. That's really fun when that happens. And then say you do actually get it working and get some telemetry out, whatever backend you're using is going to be really, really confused if you send it to two sets of telemetry representing the same thing, right? So just avoid that. And then within the OpenTelemetry ecosystem, there's a strong preference. A lot of the receivers and out-of-the-box things that generate metrics are going to have a preference for high cardinality, like every single dimension, no worries about no limits on cardinality, right? And low granularity. So by low granularity, that's like how often does the metric get emitted or scraped? In the OpenTelemetry world, we're going to be dealing with multiples of 15 seconds, right? 15, 30, 45, 60 seconds, as opposed to some tools that might prefer multiples of a single second, right? Like 1, 2, 3, 5. So that's just something to keep in mind. And then that cardinality is definitely something to keep in mind, especially if you're sending your metrics to Prometheus, where it can cause a storage explosion, or Datadog, where it can cause a billing explosion. So yeah, just watch out for that. And then the last thing, this was true. This has really not been true for a while, right? Lack of examples. There's some awesome examples. It's the OpenTelemetry demo project. That's where I pulled all the examples earlier from. Now, this project, like, if you actually wanted to build an e-commerce application, don't do it this way, because the point of this project is to show you everything that's possible with OpenTelemetry. So it's a very contrived project in that regard, but it's very awesome if you want to go like see a copy and pastable example of a production-like setup using OpenTelemetry in your specific language, in your specific use case. It's got 17 microservices representing 10 of the 11 OpenTelemetry supported languages. There's nothing for Swift yet, although I have seen that there's like a backend framework for Swift. So that might be an interesting way to get Swift into the OTel demo project. This is the front end. It's based on Google's hipster shop. So you end up with this e-commerce store that, because it's OpenTelemetry, right? OpenTelemetry logo is a telescope. So it's the astronomy store. It's the telescope store. It comes out of the box with monitoring using the OpenTelemetry Collector and a bunch of open source tools like Jaeger and Prometheus and Grafana. So this is a Grafana dashboard showing some of those Prometheus metrics that came from that span metrics connector. So we're doing exactly what I'm talking about right here. We're getting those RED metrics out of our span events. That's really, really cool. We get tracing, right? Here's a Jaeger trace directly from the OpenTelemetry demo project. This is the, I think this is the product. Yeah, there's a bunch of services in there. Here, oh yeah, here's the one from the product catalog service, right? So we have a trace from the product catalog service, or checkout service, that's then hitting the product catalog service. And here's another example of just adding some annotations, this time in Go, if you didn't like the Node.js example earlier, if you're more of a Golang person. This is really, really easy. The app key, right? That's where you're going to put things that are specific to you and that are not part of the semantic conventions. And you can kind of see some of these other things that came from the semantic conventions, like net.peer.ip, net.peer.port. These say RPC. I'm sorry, it's so hard to read. The slides are online. Okay, so I'm almost done. And hopefully we'll have some time for questions. I know everyone's eager to get going. If we have a complete observability solution, right, OpenTelemetry project isn't including some of that stuff on the right. I mentioned that there are a bunch of open source tools that do this. One of my favorites is called CoRoot. It's just like very easy to use, batteries included out of the box, and it gives you, it's OpenTelemetry compatible. But one interesting thing that I want to point out, I didn't use any OpenTelemetry for this screenshot. I just installed CoRoot and I installed the OpenTelemetry demo project, both using simple, right, just Docker Compose up, nothing else. And then CoRoot gave me all of this tracing, even though I didn't configure my collector to send the traces to CoRoot. How did it do that? Well, it used this new awesome thing called eBPF. And this is also how the auto instrumentation for Golang in OpenTelemetry, like the official auto instrumentation for Golang in OpenTelemetry, uses this. Because this is a way to actually observe compiled binaries based on the syscalls that they're making. So you can, basically this gives us a mechanism to write our own C programs. It's not complete C because they have to, there's certain safety guarantees, like we have to guarantee that our little plugin will halt. So it's a subset of C that we can write, and we can hook into the syscalls of other processes and see what they're doing on the network. That lets us get that right? Like that lets us get this. What we lose is some of the application context, right? Some of the human readable names of things like function calls and endpoints and some of that stuff is lost at this point, right? And so that's where the work in the open source project is right now, is to kind of work back through these eBPF hooks and try to get as much of that human readable context into the eBPF traces as possible. And that's going to vary, right, from language to language, system to system. In Golang, it was a little easier. It also very needed, so that's where the project has started. Okay, so closing thoughts. Why open source observability? We get vendor neutral instrumentation, which limits the blast radius of needing to make changes into our deployed artifacts. But it also gives us portable telemetry formats, which we can use to build always interoperable tool chains. That's awesome. And the final benefit is that any improvements that we make, we get to share with everyone else. We're all learning and growing together. It's awesome. I love it. Thank you so much. Time for questions. Yeah. Oh, is there a microphone?
Are there any authentication? Because I didn't see any authentication or authorization stuff in it for connecting to the collector.
Yes, you absolutely can provide like authentication or authorization.
MTLS or
maybe I'm not familiar with that one.
mutual TLS.
Yeah. That might be a way to do it. Most of the vendors that I'm familiar with are just using like API keys or auth keys.
API keys. Okay.
Yeah. The collector itself, or the OTLP protocol itself, can be HTTP or gRPC, JSON or protobuf.
Okay.
Yeah.
And one last question: what user by default does the collector run as?
I mostly run it in Kubernetes environments. You can run it as any user, but yeah, in Kubernetes, it does need some escalated privileges.
What would those be?
It needs access to the, right, depends what you want to do with it, right? If you just want to sit there and accept telemetry, expose an endpoint and accept telemetry from services, then none.
Yeah.
Right, but if you want it to be doing scraping certain things, it's going to need permission to scrape those things. If you want it to read kubelet file logs, then it would need, yeah.
Okay. Thanks.
Okay. That's really, if you want to do auto instrumentation, it will need root access. Okay. Otherwise, you can limit the access.
Okay. Thank you.
You had mentioned not needing to use metrics for aggregations hardly at all anymore. How would you deal with things like you have an access log that tracks that you could use to aggregate the number of errored requests?
Yeah.
How do you deal with the expense of storing that? Say you wanted to have like SLOs for like the past year. How would you deal with storing that if you're not using metrics? Because the only way I'm aware of doing that is you have to store access logs for a year, which is expensive no matter what vendor you use.
Yes. compression's getting better, right? So there are vendors who do that, right? I worked for one that actually stored all of the traces for 13 months. Now you're not actually storing all of them. So most vendors will have you sample the traces before they even get to the backend. I'm from the school of thought. I worked at a vendor that didn't do sampling. Not all vendors do that, but it's possible. ClickHouse is awesome. Talk to me about that. But yes, then at some point you're going to sample that historical data, right? So you're going to start doing rollups and deleting some of that data.
But then you wouldn't have an accurate number. So wouldn't it make more sense to, like, you could even generate it from the logs to aggregate that data and store that as a separate metric?
Sure.
Wouldn't that be much cheaper? So wouldn't you still need metrics for some stuff?
If you want to store the things as metrics, sure. That's how it would work here, right? Like if you use the span metrics connector, you are storing metrics because it's converting events to metrics in the agent. What I'm advocating for is like shiny pie in the sky future stuff where you're just doing it all in the back end.
Okay.
Yeah.
Cool. So right now the best approach would be wide event type things for most things and metrics where it's too expensive to do that.
Yes.
Okay. Cool.
Oh, by the way, while I'm answering questions, if anyone wants to scan this QR code, my boss would love it. It helps me keep doing this. And we're going to be doing a webinar diving into all of this stuff next week. So it'll actually be pretty interesting.
I was curious. So a lot of my company's workloads are not in Kubernetes as well. So is there any way to kind of like bridge the gap of like bare metal hosts managing things more manually compared to just the automated instrumentation of like daemon sets for Kubernetes and stuff?
Yes. The OpenTelemetry Collector makes a great node agent on a bare metal host. And there's this new really exciting specification called OpAmp, which is a specification for a protocol to actually talk back to the fleet of collectors and manage their configuration dynamically. Any other questions? All right, thanks so much. Oh, one last thing. I am an organizer for OSACon. Our CFP is now open, so if this was interesting to you, or if you have anything, OSA stands for Open Source Analytics. So if you have anything interesting to say about open source analytics, our CFP is now open, and you can go ahead and connect with me on LinkedIn or any of those other socials. And thank you so much.